Welcome back to Calculus 1. We're looking at example number 5 from the textbook. We are in section 3, module 2. The answers are in the text, so let's go ahead and see how we get those values. So this particular problem, we need to start looking at different tangent lines and their slopes. And so what we have is a graph of some function f of x, which is this red line, and we're going to let g of x be the slope of the line tangent to the graph at f of x, okay, or of f of x at the point x f of x. So what this means is, for example, g of 1. G of 1 in words, so when you read through this, it asks the output value here, the number that we're going to get. This number is the slope of the tangent line at, I should write it like this, at 1 comma f1. So 1 comma f1. Okay, so what it says is this number right here, if I go to 1, I go to the function value, I want to get an estimate for this slope. Now if you look, this line, it looks like goes 1 up, 1 over. So it looks like g of 1, the slope value is 1, so g of 1 is 1. Because this should be the slope value, the m value. So let's look at g of 2. Well, g of 2, we go up, and it looks like that guy's flat. So g of 2, the slope of the tangent line at 2 is 0. Let's look at g of 3. So we go to g of 3, we go up. Okay, here's our line, and it looks like this is going to be close down here. Okay, let's see here if I extend this line. Ooh, that was not pretty. Close enough. Okay, so we extend that line. So here's 4, here's the height. It looks like we're going down by approximately 1. So I'm going to say this is roughly -1. Right, down 1 over 1. When does g of x equal 0? Well, it equals 0 at 2. So g of 2 is 0, and g of 5 is 0. So we would say, when does, let me erase this now up here because I've already answered that question. Okay. So when does g of x equal 0? When x is equal to 2 and 5. At what values of x is g of x the largest? Okay, so what they're asking is, when is the slope the most? Okay, well, if we look here at the different slopes, and this one's not bad, but it looks like probably somewhere in here there's a point, and it's got a nice high slope. But if you notice, that's going to be, it looks like, the largest. So I'm going to say at approximately 1.5. Somewhere between 1 and 2. Now this is the hard one. Sketch a graph of all of those different tangent lines. That's not easy to do. Okay, now there is a graph in your book. Okay, so you can follow along to that, but or you can take a look at that. But I'm going to try to graph this guy out here for you. Okay, so let me. It actually is almost easier probably to do it on the same graph. Okay, but I got this other one over here just in case I need it. So the slopes here between, let's start at 0. Okay, so from 0 to 2, all of the slopes are positive. So from 0 to 2, all of the numbers here are more than 1. So these are all going to be positive numbers, which means we're going to be above the axis. At 2, we hit 0, so we know the slope at 2 is 0. We also know the slope at 5 is 0. So 1, 2, 3, 4, 5. 6. So here's 5. We also know at 5, the slope is 0. We know that the slope is pretty constant between 2 and 5. Okay, so it looks like there's like a quick turn, right? And then the slope is negative, but it's constant. So it looks like this probably comes down and is flat like that. Okay. So you understand that this each of the tangent lines along here all look like they have the same slope. So they're all, since all the slopes are the same, this guy should be flat in here, relatively flat. Okay, now between 0 and 2, it looks like the slope increases and then it quickly dives down. So it increases slowly. So we're going to increase very slowly. Okay. So our rate of our increase it is increasing, right? But then it's going to drop back down, and it does so very quick. Okay, so we'll put something like that. Okay, and then down here it's also increasing. So that's roughly what our sketch should look like. Okay, not perfect, but pretty close.